All right, let's talk about the next section in chapter 3, which is going to build on what we talked about in section 1. So we talked about transversals, how those were lines that cut through two other lines. We talked about angle pairs like alternate interior and alternate exterior corresponding. We're going to kind of expand on some of those ideas today, especially as they pertain to parallel lines. So we're going to be talking a lot about when lines are parallel, what's going to happen with these different angle pairs that we discussed in the last section. So we start with our corresponding angles. Now again, the main idea here is that our lines are parallel to each other. So this only works when our lines are going to be parallel, and we know that because these little arrow symbols on the lines are going to tell us that the lines are parallel to each other. So whenever you see those little arrow markings, they're telling you that you have parallel lines. So corresponding angles, if you remember corresponding, okay, that meant like same position. So same position on or within the group of angles. So we have the top group and bottom group in this case. So for corresponding, if I started with angle 1, for instance, the corresponding angle to angle 1 would be the other angle in the top left corner, which would be 5. So those are both top left angles within their groups. So based on this theorem, angle 1 and angle 5 are going to be congruent to one another. Also then, we have other pairs of corresponding angles. So for instance, angle 2 is in the top right. Well, that would also match up with the top right down here, which is angle 6. So angle 2 would be congruent to angle 6. And then we can continue along throughout our picture here and match more up. So I've got angle 3 in the bottom right, and angle 3 is going to match up with angle 7. So both are bottom left, so we match them up. And then our last angle pair, angle 4 and angle 8 are both in the bottom right, so angle 4 is going to be congruent to angle 8. So those corresponding angles, when you have parallel lines, are always going to be congruent to each other. So corresponding angles are always the same, meaning if I were to give you that angle 1 was 40 degrees, that means angle 5 automatically has to be 40 degrees. Or if they told you that angle 2 was 5x plus 4 and angle 6 was 4x plus 23, you would set those two equal to each other and then solve for x. So corresponding angles are going to be identical to each other as long as you have parallel lines. So then the other types of angle pairs that we talked about, the next one we want to discuss would be alternate interiors. So again, main idea, we have parallel lines marked with those little triangles there. So I've got my parallel lines. When I look at alternate interior angles, so those were the ones on the inside of the two lines being cut. So if I'm looking at my picture here, my interior would be in between the two lines. So when we talk about the alternate, we're talking about on opposite sides. So for instance, angle 3 is on the interior. The alternate angle to angle 3 would be angle 6. So it's still on the inside, but now it's opposite sides of the transversal. So angle 3 would be congruent to angle 6. We also have other interior angles. So we have angle 4 over here. Angle 4 would pair up with angle 5 as they're on opposite sides of the transversal, but inside the two lines being cut. So angle 4 would be congruent to angle 5. And then those are my only alternate interior pairs in this particular figure. So those are going to be congruent just like corresponding. So then we can use those to set up equations or find missing angles. The next pair is the alternate exterior angles. So alternate exterior, again, we're talking parallel lines. When we talk alternate exterior, the key here is we want to be on the outside. So exterior would be on the outside of the two lines. So there's a space up there and a space down here where we have our exterior angles. So as we're looking at this, we have one exterior angle, angle 1, which would match up with its alternate, which would be angle 8. So they're on the outside, but opposite sides of that transversal cutting through the picture there. And then we also have another pair of exterior angles. Angle 2 here would match up with angle 7, as they're on opposite sides of the pink line and they're exterior to the two being cut. So angle 2 and angle 7 would be congruent. And so again, given a picture, we can find the missing angles, setting them equal to each other. We could find x if we had an equation. Whatever we need to do there, we just set the alternate exteriors equal. So they're always going to be the same. Now the only angle pair that's a little bit different are the same side interior angles. Now same side interior, remember we also said same side, we might see the word consecutive being used. So we can call them consecutive interior angles, or the homework or quiz or test might call them that. So it means the same thing. But in this case, again, we're talking with parallel lines. If we want same side interior angles, again, we're going to be going to the interior of our two lines. So if we're looking at the interior, now we want to be on the same exact side. So if I'm looking at angle 3 on the inside, it's going to match up with angle 5 this time, also on the inside, but now we're on the same side of the transversal. This time, instead of being congruent, this angle pair is going to be supplementary, meaning they're going to add to 180. So if I take angle 3 plus angle 5, I'm going to get 180 degrees. Okay, so we're going to get 180 degrees when we add those together. And again, we have more pairs here. Angle 4 can match up with angle 6. They're same side interior, so the measure of angle 4 plus the measure of angle 6 has to equal 180 degrees. So if they're on the same side interior, they're always going to add up to 180 degrees. So now if we put this into practice a little bit here, when we get a little more complicated pictures, the first thing we always want to look for are which lines are parallel. So notice these little arrows here are what we're keying in on. So as far as this picture is concerned, the left line and the right line are parallel to each other. Now this top line and bottom line are not. What that tells me right away is the only angles I can match up together are going to jump from one parallel line to the next. So I can match up any angles in here, or I can match up any angles down here. But I can't, for instance, put angle 10 with angle 6. That's never going to work because they're not part of the same parallel lines or same transversal. So I can't go across unless I have a transversal connecting. And then I can't match them unless they are parallel to each other. So I can only work within these two circled areas. So when the first question asks, which angles are equal to 67 degrees? Well, so they gave us this 67 degree angle right here. Okay. Now, as far as which other angles would be 67, well, we can look for corresponding angles, we can look for alternate exterior, we can look for alternate interior. All of those would be congruent or equal to this particular angle that we're looking at. So if I look at here, I can only stay within this circled area now. So where I had circled initially, I got to stay within those boundaries. So 67 would correspond to angle 6. So angle 6 would have to have a measure of 67 degrees. So those are corresponding. Or I can go alternate interior. So this is on the inside of my two lines that are parallel. So alternate interior would be angle 5. So those are alternate interiors, which means they're both going to be 67 degrees. Now, from here, I could go about this a couple different ways. The other angle that's going to also be 67 degrees is angle 2. Now, if I notice, angle 2 here is vertical to my 67 degree angle. So don't forget that we have other angle pairs that we haven't explicitly stated in this chapter that come from other chapters like chapter 1 and 2 when we talked about vertical angles. So vertical angles are always congruent, which means angle 2 would also have to be 67. Or we might recognize that angle 2 is alternate exterior to angle 6. Or we might notice that angle 2 corresponds to angle 5. And so we get 67 either way. So vertical angle, alternate exterior, corresponding, I get lots of ways to show that that particular angle is 67 degrees. So as I'm looking here, those three angles, 6, 5, and 2, would all have to be 67 degrees as well. Now the next question says, what's the measure of angle 4? So angle 4 is right here. So we're looking for that angle measure there. Now I can do this a couple different ways. I know that these two angles here, my 67 that they gave me and angle 4, are same side interior angles. We just discussed that same side interior angles have to add up to 180. So if I want the measure of angle 4, I'm going to take 180 minus 67, and in this case I would get 113 degrees. The other thing I might notice though, since I already found some of the other angles that are 67 degrees, right here, angle 4 and angle 6 are a linear pair. Well, linear pairs from chapter 1 always add up to 180, so I get the same exact idea, but using linear pairs instead of same side interior. So there might be more than one way to find your particular angle measure in question. Now when we go to the next question, what's the measure of angle 10? Now if I look at angle 10 is now down in this region here, so I can only be working with these angles down here. So from this point on, these angles are out of the question. I can only be working with these angles that are down below. So if I want the measure of angle 10 right here, well, the only angle I know down here already is this 115 degree angle. Well, if I look closely, angle 10 and that 115 are alternate interior angles. So if I have alternate interior angles from our previous discussion, we know that those are going to be congruent, so the measure of angle 10 must be 115 degrees as well. It asks about the measure of angle 8 then. Well, for angle 8, we're looking at this angle right here. Now we could do this a couple different ways, although since we just found angle 10, which was 115, we know that 8 and 10 form a linear pair. So if I want the measure of angle 8, I'm going to take 180 minus that 115, and so I find that angle 8 would be 65 degrees. So I don't even have to use one of the new angle pairs. I have a linear pair which allows me to set those equal to 180 and solve. So when you're looking at these pictures, be aware you can only jump from one parallel line to the next. So those are extremely important to be able to identify right off the bat. Here's one that has a little bit more simplified picture. So if I'm looking at this picture here, it says what's the value of x? So again, first thing I need to note, those top and bottom lines are parallel to each other. So if I look at the angles they gave me, so this 3x plus 4 and this 15x minus 32, what I notice is they're on opposite sides of the transversal and they're both on the exterior of the two lines being cut. So if they're on opposite sides and exterior, that means 15x minus 32 has to equal the 3x plus 4. And that's because these are alternate exterior angles. So I know they're equal to each other. Now if I want to find x, all I have to do is solve. So I subtract 3x from both sides. 12x minus 32 equals 4. Add the 32 to the right, 12x equals 36. And then if I divide both sides by 12, x would equal 3. So when they give you problems like this, if they're one of your angle pairs that we know, they're going to be equal to each other, or in the same side interior, we're going to have add to 180. So you're just going to look out for what type of angle pair it is and then solve from there. Last example here says if the measure of angle 1 is 105, so right here they're saying this is 105 degrees, find the measure of each other angle. So again, we have lots of different ways to go about attacking this problem. One thing that we note here, top and bottom are parallel to each other, and then left and right side are parallel to each other. Now from here, I can't jump from angle 1 here down to say angle 8. There's not a single line connecting 1 to 8. So if I tried to go from 1 directly to 8, there's no line that takes me there. But if I wanted to jump from 1 to 3, I have this line along the left that takes me from 1 to 3. So it's kind of like traveling from city to city. If there's no road to take you directly to that city, you can't travel between. Okay? So just be aware of that when you're going through some of these problems here. You can only pair up angles that are part of the same road. So if I'm looking at this, one that I might notice right away, angle 1 and angle 2 are a linear pair. Well, so that means that the measure of angle 2 has to be 180 minus 105, or 75 degrees. Okay. So angle 2 is 75. I can start solving for any of the different angles just depending on how I want to attack from here. When two sets of lines are parallel, it makes things a little bit simpler. So I can jump from angle 1 to angle 3. Those are corresponding angles. So the measure of angle 3 would be 105. So angle 2 we found because they were a linear pair. Angle 3 we found because they were corresponding angles. So this is going to be 105 because it has to be the same as its corresponding angle 1. And then angle 4 would be 75. Now this could be either because of the linear pair here, or it could be corresponding with angle 2. So either way, we find that angle 4 is 75 degrees. Now if we try to jump over to the other angles, again we have left and right being parallel, so it's okay to jump from one to the next. Well, I can find the measure of angle 5 by using alternate interior here. Since angle 2 is 75 degrees, angle 5 must be 75 degrees because of alternate interior angles. Same thing with angle 6. If I want the measure of angle 6, I've got alternate interior angles here, so that's going to be 105 degrees, and it's alternate interior angles. If I want to go to 7 and 8, so here was 75, here was 105. If I want to go to angle 7 corresponds to angle 5. So it's going to be 75 degrees because they're corresponding angles. And then angle 8 corresponds to 6, which was 105, so angle 8 must be 105 by corresponding angles. So whatever angle pair you can find within the picture, you just use whatever property you know is associated with that to set up and solve for the missing piece. So it might be setting them equal to each other, might be subtracting from 180, but in either case, you're just going to use whatever angle pair you can find and set up and solve. So with that, you should be able to attack the worksheet, which is the homework for tonight. As you're working through the worksheet, if you have questions, again, make sure you ask. So email, ask in class, maybe come in before school, check the answer key when it comes out. But whatever questions you have, make sure you get those answered. Try to complete whatever you can on the worksheet for this section.